Hello world, welcome back again to Teacher Babi and Muita channel. Uh, Today we are continuing with Organic Chemistry 1 that we started the other time, and our objectives of today we have highlighted. We're going to start with the sources of alkanes. Sources of alkanes. But before we proceed with sources of alkanes and other lesson objectives for today, let's first talk of whatever we discussed in a short while. So in the last lesson, we defined organic chemistry 1, whereby we said it's the study of carbon compound excluding oxides and carbonates. The oxides and its carbonates, we study only carbon compounds while excluding. It means that we don't include any oxide of carbon while studying organic chemistry 1. Also, any carbonate of carbons compounds while studying in organic chemistry 1. That is what it means when you say exclude. It means you won't include it. So whatever concept we are going to tackle, it's only majorly concerned about carbon compounds, no oxides, no carbonates. Now, since we say that it deals with carbon compounds only, therefore, why carbon? That was our major question. Why carbon? Why carbon? Why carbon in the organic chemistry 1? Because it's a major element that is being taught under organic chemistry 1. Then we should ask ourselves that question: why carbon? Why carbon? So these are the reasons. Carbon is a catenate. A catenate element. I will explain what catenate means. Remember, carbon always with its 4 valence electrons bonds with all of them to form strong covalent bonds with its carbon atoms and also with the other atoms of other elements. So it can bond with those 4 carbon valence electrons with other elements. So why is it catenate? And why and what's this meaning of the word catenate? Let's discuss it here. When we say that an element is catenate, so major concern, which is carbon, these are the reasons. Number one reason, it can combine with hydrogen, halogen. That's the reason number one. It can combine with hydrogen atom and also other halogens. Reason number two, carbon atoms combine with other atoms to form long chains. to form long chains which are straight chains, comma, ring chains, and also we have branch chains, branched chains. So those are the reasons. Okay, let me add another number 3. It forms very large number of compounds. So that is the reason as we say carbon is a catenate element. Carbon is a catenate element. Those are the reasons. Carbon as a catenate element. Now, if maybe you're not understanding sometimes here, let's break them up. These straight chains, also ring chains and branched chains. Let's break them up now. Let's see an example of a straight chain, equally an example of a ring chain, and an example of a branch chain of carbon long chains. Of carbon long chains. Now, a straight chain could be like this: the appearance of a straight chain made up of carbon atoms. We have C, C, C. That's very straight. We call it a straight chain. We also have ring chain. We have ring chain, C, C. That's a ring chain. As you can see, it appears in the form of a ring, right? You are able to see why it's called a ring chain, because it appears in form of a ring. This one is very straight. And also branched chain. So branched chain will be appear like this. A branched chain will appear like this: carbon, 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 carbon. So we can see it has already branched. Were it that it was straight, then the carbon atom will be in front of this carbon, which is letter C beyond here. So those are the reasons as to why we call carbon as a catenate, or carbon is a catenate. You can also refer it, carbon is a catenate element, with the reasons. Number 1, it combines with hydrogen, halogen. Number 2, carbon atoms combine with other to form long chains, which are straight, and we have shown an example of straight chain, ring chain, and branched chains. Now, another key point to remember under organic chemistry 1, we defined hydrocarbon, where we say that we defined hydrocarbons as compounds which are made up of hydrogen and carbon atoms only. Only. Underline this word only because we only have, let's break this name, hydro and carbon. So we only have hydrogen in it. Hydro, we have only hydrogen in it, and carbon, of course, is the carbon element in it. So hydrocarbon. And our topic, which is organic chemistry 1, deals with only hydrocarbons, right? So that was an introduction of previous classes that we tackled yesterday. Now, today we were to start with the sources of alkanes and move ahead to the rest of the subtopics. Sources of alkanes. So the sources of alkanes, we were to group them here. Allow me to grab so that I give you a good flow of the notes. Sources of alkanes, right? So our number 1 source was crude oil. We have crude oil, we have biogas, and also we have natural gas. Suppose that a person asks you, where do you get now these alkanes? Don't wonder where to get them. Just tell the person the sources of alkanes are crude oil, biogas, and natural gas. So the natural gas, it's just simple. Most of you have encountered this natural gas, though you can't recall, you've encountered natural gas. An example is methane, ethane, propane. These are the examples of natural gas. Methane, ethane, and the alkanes are mostly used in for domestic purpose. That means the one that we use in the cooking or gas cookers. Those are the natural gas we are talking about. We also have the crude oil, which comprises of so many components. In the crude oil, it has so many components indeed. So there we have lubricants, which is lubricating oil. We have kerosene, right? We have petrol. We have bitumen. We also have refinery gases, whereby this refinery gas is now the what we call alkanes, right? So refinery gas here we can have ethane. So this is where we have these alkanes and refinery gas. So for us to obtain refinery gas from the crude oil, there's a method that's called fractional distillation. Distillation, which separates the crude oil components. Somebody may go ahead and ask you, why do you think the answer provided, which is fractional distillation, is applicable in separation of crude oil? It's because of due to different boiling points. Different boiling points. Due to different boiling points, right? So for us to get refinery gases whereby we have alkanes inside there, we have to take these components in under crude oil, all of them in a fractionating column. So all of these, we take them in a fractionating column, right? And a fractionating column, it's where we get now uh, petroleum distilled off at a certain boiling point, kerosene also distilled off at a certain boiling point, lubricating oil also to bitumen, until we have refinery gas which distill off at a very low boiling point. Now, having understood that the sources of alkanes, uh, which are three, but we always say that one major source is crude oil. Crude oil remains the major source. Major source. Crude oil remains to be the major source of alkanes, right? Have that in the back of the mind. Crude oil is the major source of alkanes. Someone could go ahead and ask you, after they have drawn that diagram of a fractionating column, which is like that. Suppose that this is refinery gas on top here. And of course, we have identified here we have heater, very strong heat applied so that they can be able to distill off. So that they can be able to distill off at different boiling point. We have here bitumen. We also have here such kind of kerosene and so on. Someone asks you, name the one use of refinery gas. I started by saying that these refinery gases are the one we use in the houses for gas cookers. So the possible answer you could give is domestic use. Laboratory gases, laboratory gas also is a good answer. So that is it. That is it about sources of alkanes. That's all about it. Now, let's proceed again, hoping that I'm not leaving anybody behind. Let's proceed. Our next subtopic will be cracking of alkanes. Cracking of alkanes. There is one key thing that we will always remember about. We started with it by stating that they form carbon atoms, forms bonds forming more carbon atoms, forming a very long chain. So we are not interested in the long chain of carbon. We're not interested in long chain because the long chain cannot help us in cooking neither laboratory gas, neither anything that we need of alkanes, right? So we always use short chain alkanes, which are methane, right? Ethane, propane, and etc. we always use short chain alkanes. Long chain, they must be broken so that they can be able to be used into, they can be able to be put into good use. So we cannot have a long chain, an example, carbon, 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 carbon. It cannot help us. We must break it so that it can be the range of methane to the cane, from methane to the cane. Or for the, in case we need the gases where we reach at the propane, there we